Welcome, everybody. We're going to give it a few seconds for everyone to log in and join us. We're expecting actually a full house for today's session. And I really do apologize for anyone who has heard me say this no less than 7 times over the past 2 days. But please, if you are in here, make sure that your name is listed by both first and last name. That's how I know who to give the continuing education credits to. So if you can highlight over your name, rename yourself. And if you can't figure out how to do that, feel free to chat directly to the AIA Pittsburgh account and let me know what your first and last name is so that we can make sure you get these credits. And I think with that, in the interest of time, we can get started. So welcome, everybody. I would like to introduce Tyler Swar with Performance Roofing Associates. They are the session sponsor for today's session, Modern Documentation Technologies, a guide for design professionals. So Tyler, with that, I will hand it over to you.
Kira, thanks so much. Thanks for having Performance on as a sponsor. This is Performance's 3rd year in a row as a sponsor of Build Pittsburgh, and we expect several more to come. Great event that we really enjoy participating in. So as today's session sponsor, I'll steal a few of your minutes to talk to you about who we are. Performance Roofing Associates is commercial roofing representative. So we're a sales entity, but what I specifically do is assist the design community. So really I'm here to help. And if you remember one thing about me, that's what I'd love it to be. Any part of your commercial roofing, so a flat roof or a standing seam roof, we represent several companies that manufacture products and can help you through any part of the design or execution process of that. So just to highlight a few things we can help you with: tapered insulation design. So we do have a full tapered insulation design team in-house. Roof survey core cuts, budgeting. So it'd be at the beginning of your project, really help you talk to your building owner, or at least get a budget number for the upcoming year or project cost. Specifications, of course, so we can write you a one-off spec for your project, or if you're in the habit of using a master spec. Codes are ever changing, products are ever changing. So if that hasn't been updated a while, that's something that we offer. And then of course, code compliance and wind uplift, one more thing that's always evolving. So we're happy to look over your spec or run the calculations for you, just in an effort to make sure you're getting what you need out of your roofing project. So I know all your offices, although many of you haven't been there in a while, are full of beautiful pictures of the design work you've done, but I would wager that none of them show the flat roof on top of the building. So we know it's not the most exciting thing, but it is something that's obviously very important. Protect all the nice things you guys design inside. So when you do run into that and you have questions, please give us a call. And with that, I will throw it over to John, so you can start your session. Thanks so much for having us, and enjoy.
Alrighty, let me just get the screen shared here somehow. All right, so thanks for the intro, Kira and Tyler. Just by way of introduction, my name is John Evans. I'm with LGA Partners, an architect. I've done a lot of preservation work in my career. You'll see a lot of the projects that we present today involve historic structures, but really a full range of work that we're going to kind of display today. And taking advantage of the remote nature of this, I've asked 2 consultants who I've worked with personally for probably nearly 15 years now to join us. Peter Oslestad, who has a preservation consulting firm in Virginia, and Sean and Matt, who are with Langen in the New York area. So the 4 of us are going to present today. By way of introduction, so we called this sort of a guideline for design professionals. And the idea behind this was really to talk about different documentation technologies that exist today, how they've evolved over the past decade, 15 years, and how that relates to what architects and engineers actually need to do. So the idea of not documentation as an exercise in its own right, like a HABS project or something like an archaeological site, but really how do these technologies relate to practicing professionals who are using this documentation to deliver projects. We're going to mostly focus on two technologies simply because they're the most prevalent in the industry: laser scanning and photogrammetry. And then just talk about a couple of themes that I think run through the whole presentation. We may not touch on them explicitly, but they're really things that I wanted folks to kind of have in mind. And I'll go through these in a little more detail. So the first, laser scanning, we're not going to get into the details of how it works, but essentially this is the LiDAR system that you see on self-driving cars, where you're actually actively sending out a signal, receiving that signal back, and using it to develop typically a three-dimensional point cloud of the objects that you're scanning. Cars are doing this from a single moving point, and they have to do it really rapidly. For buildings like the old TWA terminal that you see on the right, it's done from usually a series of, it could be 50 or 100 stationary locations, but the principle is kind of the same. Photogrammetry, which I think people are a little less familiar with, is actually a technique that uses the idea that by identifying common points on a photograph or a series of photographs, you can then determine precisely where those photographs were taken from. And you can actually start with multiple photos that have overlap to construct a 3D model of the geometry based solely on those photographs. So two very different techniques, and we'll get into how they're different and what those differences mean in a practical sense later on in the presentation. Something I think is worth thinking about as we talk about these different technologies is the idea that, in our industry, there are technologies that are, I call them convenience technologies. And it sounds silly to say, but I consider the transition from hand drawing, which you see on the upper left, to AutoCAD really was a convenience thing, right? The product is still the same. You're developing a 2D line drawing. You're using a different technology to do it, but at the end of the day, it's still two-dimensional. When you look at something like the transition from, a 19th century map to GIS, that's actually transformative. You're taking something that was always just a two-dimensional depiction and you're layering onto it a database of information that you can access. So I think as we go through these things, especially when we start to talk about drones, it's important to really think, okay, is this something that's actually transforming the data, transforming the way we can work? Or is it just something that's convenient? A drone, for example, flying a drone is certainly easier, but theoretically, at least, you could obtain the same data most of the time if you had, say, a 100-foot lift that you could move around the building really quickly. The drone's saving time, it's saving money, but it's not actually transforming what you can achieve at the end of the day. Similarly, I think it's important to think about the difference between recording technologies, whether it's a tape measure, a camera, or a laser scanner, versus the output. So the output may be a simple 2D floor plan, regardless of the technology that it was recorded with. And a lot of that also is woven through the presentation that we're going to talk about today. And then finally, and this is kind of funny since Tyler did his introduction, but I had this slide queued up. And what I wanted to show is that, there's this idea of documentation and a temptation to say, let's just capture everything. And let's capture it at the highest possible resolution we can, and then we have it all and we can figure it out. But a lot of times that ends up really costing money, resources, time, without delivering real value to the project. And this was actually an example of a point cloud where we determined that because of the nature of the project, we'll talk about that a little later, we didn't actually have to scan the roof at all. So we didn't really need the data on the roof as long as we can accurately capture the exterior elevations. So with that, I'm going to turn it over to Sean and to Matt, who are going to kind of talk a little bit about laser scanning.
Yeah, thanks very much, John. Yeah. Hi, my name is Sean Higgins. I'm from Langan Engineering, and I've been involved for quite some time with John and others doing some laser scanning work. And here's an image of a typical scanner that we're looking at on the left-hand side of the image here. We wanted to go through today some of the services that you can seek out and get proper documentation of existing conditions and the ways that you can do that. And there are a number of different ways of doing it. And laser scanning alone has evolved so much over the past 20 years that things change pretty rapidly, and there are a number of different ways of getting the information that you want for existing conditions. This scanner is pretty typical of what we use for high accuracy terrestrial scanning. But recently, probably over the last 10 years, there's been some great advancements in mobile mapping, which is putting a scanner basically on the back of a truck and driving that along at highway speeds and gathering this similar information so that you're getting point cloud data of existing conditions that you're driving by. So you get a huge amount of data over a huge area in a pretty short space of time. The equipment has changed in that realm quite a bit, but also in just that terrestrial laser scanning has changed quite a bit also, in that you can now get these scanners placed on a backpack. So you can actually walk through a building or even have a handheld wand type unit and gather existing conditions of building interiors. Similar to what John mentioned from the photogrammetry, to get stitched together by finding common points and then putting those together and creating pretty decent output. The big difference here is in the equipment. It's a little bit cheaper now, but you just need to be careful with the accuracy. So it's very, very important that you're very specific about what you need as a deliverable, what the accuracies are that you need when looking at contracting with somebody. And then Matt will go through here some of the opportunities and challenges and a little bit more detail about the scanning services that you can sort of seek out from similar providers.
Thanks, Sean. Yeah, so actually, John talking, about this presentation, Mr. Evans, John, he brought up a good question. He said, hey, let's look 10 years ago and compare the differences 10 years ago to today. It was kind of funny because it was like a trip down memory lane. So this is what scanner was pretty common 10 years ago. On the left-hand side, you can see, one of our crews working. This particular project was on the side of a highway, but there was 4 main parts of what they needed to bring. The scanner, on the tripod, a generator, a source of power, because, the scanner used a lot of energy, and batteries weren't that strong. A laptop. So most scanners had to have a laptop connected to it for collecting the data and running the scanner. And then also number 4 is the little yellow box the guy's sitting on, a chair, because scanners would take forever, really, really slow. It would take a lot of time to collect a lot of data. And then on the right-hand side, you could see, really what our what the data was. And that was always the biggest challenge, is what do we do with all of this information? What do we do with all of this data? And, at the time, this is looking in AutoCAD, I think it was 2009 version. But how do we use all this data? What do we do? And the data itself is a little bit grainy. John, if you could go to the next slide. So we'll fast forward 10 years. A lot of advancements have been made in scanning technology. The speed of scanners, how much data they collect, the resolution of that, the accuracy. So you can see now how much different scanners are now. I mean, we're talking the manufacturers of the scanners, they like to brag now, saying, oh yeah, we can get up to 1 million, 1.5 million points per second. So the scanners have gotten really faster, and thanks to a lot of the advancements in the hardware, they've also gotten smaller. So now, no longer do we have to go out and bring generators and laptops to run the scanners. Most scanners fit on top of a tripod and are pretty much push button technology. The scanner on the right there, you see my friend Juan using, actually comes with a 512 gigabyte USB drive that's in there. So as he's scanning, if that gets filled up, he can pull it out and put in an empty one and continue scanning. And it's really push button technology. The scanners now too, the mirrors go all the way around, whereas previous scanners, they could only go to a certain range. So now we're picking up everything. John, you want to go to the next slide? And so with these advancements in technology, brings up some, especially in the size reducing capabilities, brings up some more interesting equipment situations that we've come across. So left-hand side, this is a scanner. And right now we can go to a lot of places where we couldn't before, which is important. So we'll talk about that and some of the challenges with scanning. One of the biggest challenge is that with laser scanning is that it's a line of sight technology, meaning if you can't see it, the scanner's not going to be able to see it. You know, there is some non-destructive ways to get inside of walls, but we can't see. You know, one of the biggest questions we always get is, "Hey, can you tell me where the studs are on the wall, or can you tell me where the pipes are on the wall?" You can't do that because again, the laser scanning is line of sight. We run into some issues with shadowing, especially when you're trying to scan on top of tall buildings. So people have developed some hardware, and so this is a piece of hardware where the scanner, we can actually stick the scanner out over a ledge to scan the side of a building that we would normally not be able to get to without having to get, you know, a lift or scaffolding. So it's brought us some pretty cool, interesting places now. On the right hand side, as Sean was mentioning earlier, was the mobile scanning. So that's really become a big development over the last probably 5 years, is the use of mobile scanning, where the scanners aren't fixed to one place with a tripod. You can now put it on top of a vehicle. This is a truck. We put them on top of carts. You could even have them on boats. We've even done a few projects with scanning from boats, and it's really opened the way, how we're able to use the scanner. John, if you can go to the next slide. So, some of the opportunities in scanning, I kind of wanted to highlight that, it's both big projects and little projects. 10 years ago, a lot of times when we were making presentations and talking to architects and clients and owners about doing scanning, they said, "Oh, my project's not big enough for that." But with the reduction in the size of the scanners and the cost involved with that and the processing, we're doing a lot of smaller projects now too, where, this on the right hand side, that's a tenant fit out on an office building, and the contractor and the whole design team, actually, was a design build project. They were like, "Well, we had to scan it. Why wouldn't we scan it? It won't take us that long, and it takes a lot quicker to do smaller projects, as well as the large, complicated projects like you see on the left." Next slide, John. Also, modeling. So there's a lot more use of BIM, especially over the past 5 years. A lot more companies now are using BIM. So 10 years ago, even before that, a lot of scanning, really we were taking all that 3D information and kind of just reducing it down to 2D drawings. Now with the rollout of BIM and the popularity of BIM, scanning is perfect for that because it collects a lot of information in 3D, and we were able to use this to create the existing condition models that we hand over to other teams to use that. I think we have one last slide. So the one last thing we were talking about is some of the challenges. So, some of the challenges and the challenges that we're still seeing, as I mentioned, are the line of sight limitations of using a laser scanner. So the scanner on the left, that's just from a single scan, kind of highlighting the shadows. It's actually kind of funny because it was hard for me to find some tough, challenging things, because we put a lot of effort when we're doing our field scans to make sure that we get inside of any kind of, shadowed area, do multiple scans. It adds to the field time, but the worst thing you could do is, spend a couple of days working on a site and then miss the most important part. So doing that is very important. And the other challenge on the right-hand side is it's still a lot of, physical work, and it still requires a lot of access. You can see my friend Filner there, crawling around. This was a project where we had to scan some tunnels, and the tunnels got shorter and shorter the further down we went along. And of course, this was at the end of a long day, but you still need to have somebody in there with a scanner. We're not at the point now where we could just put a robot in there, let the robot go. You still need to get personnel in there. And again, the line of sight. So question that comes up a lot is, hey, can we use a lift to do that? And we can, to do a scanner, but you really need a stable platform. So there's a lot of challenges, when you start getting into trying to get higher up on buildings to get some stuff that you may not see from the ground level. So that's one of the challenges that, we still run into. So Now I'll turn it over to Peter and he can talk about his work with photogrammetry.
All right, so everybody can hear me all right? I don't see my picture coming up there. I'm not sure.
Yep, you're good. You're on video.
Okay.
Mostly
right.
your beard.
All right, so let's go to the next slide. I got started with working with photogrammetry 30 years ago in the 90s when I was working as an architect in France. And I found a little company that was doing work at the Notre Dame, and took a career change and started wanted to understand what this was like, and eventually came back and started a company here in the US. And photogrammetry has been really an interesting thing for me. It really does predate, the notions behind photogrammetry really do predate even photography. It has to do with the relationship of a single point and an image plane. And this drawing on the right, which is from the 16th century by Albrecht Dürer, is sort of showing how a way of understanding an object but at a single point of view through a picture plane by tracing rays as it passes through a plane to create a perspective image. So the notions are ancient. But what happened in the late 80s and into the 90s was that computational power allowed these situations to be mathematically modeled and then back calculated so that you could establish camera relationships and then pull 3D measurements out of them. So it was a big leap forward. Go ahead to the next slide. So when I was in France, we were working, this is on the left is the Basilique Saint-Denis, and we were basically making drawings that were being plotted and put onto paper and then given to stonecutters in the field. When I came back to the US in '92, CAD was starting to take off, and so a lot of the drawings I made were for print, but also for people using CAD. And back then, photogrammetry did not produce point clouds. They were just, you were using photogrammetry to determine XYZ locations that were specific to a point on the building, but then you could connect them together and make these sort of skeletal 3D drawings like you see on the left. And they served really as field notes for making measured drawings. And on the right is a HABS project that I worked on, where the deliverable is a 2D drawing. My field notes essentially was a 3D drawing inside that I was looking at, but interpreting and turning into a 2D drawing. But the points I was choosing, we used to call them smart points because you weren't looking for an edge from a cluster of points. You were you were asking of the photos, what can you tell me about the building? And you were saying, I want to know this particular point. And all of your points could be traced back to a photo identifiable location. So you were sure that you were talking about one corner or as opposed to another corner because you were manually selecting it. And then when you were working with flat planes, such as on the right is the tomb for George Washington at Mount Vernon, well, him and his whole family. We were charged to locate every single brick in this, and so what that meant was using the smart points to get a layout of the planes, but then we were tracing on images to get the actual photos, which was obviously very time consuming. And so around 2000, I started thinking, what if we combined digital photography, which was just coming around then, with line drawings. And so this project, this is a theater building at Wesleyan University in Connecticut. And so a lot of it are made up of cut stones. These I measured with photogrammetry, making a line drawing. And then for all of the ashlar pattern stones, I thought, what if we captured those and represented them with flattened digital photographs? And these were shot with a Nikon, was it 990, which is a 3.2 megapixel camera. At the time, it was pretty good, and it did the job. We were able to, this was using Photoshop to sort of tweak everything to make it fit, and we did our best to make it as accurate as possible, so that an architect could map a single conservation technique to a single stone, and get the contractors to come do the right thing in the right place. And then as the 2000s moved on, this notion sort of became part of the photogrammetry software, so that this is the Virginia State Capitol we're looking at here, so that you could take a grid of photographs such as these, and then next slide, use photogrammetry to create a line drawing to get measured points. That's what all the little purple dots are, numbered points that are accurate, extremely accurate in 3D, and then to interpret that into a 2D drawing. And then, since we knew a lot about the cameras themselves, the camera and lens combinations, we could very precisely remove the distortion from the images and combine them together as an overlay here, and then blend them together and come up with an image like this, where we had to ask ourselves, is this a drawing? Is this a measured drawing that looks rich, has the same rich data as a photograph? Or is it a photograph that behaves like a measured drawing? And of course, it's both of those things. And this was sort of we called these hybrid drawings at the time. And what we were able to do going forward from that point was to mix these rectified images together with the line drawings. And in some cases, we would make a detailed drawing of a structure, and then we would have to figure out which planes we're going to treat with rectified photography. And together it would could make a very complex, large drawing. Or this is the gardener's house at Mount Vernon. We could also do it really kind of small scale and intimate, and also go inside the building and connect the points, the rectified planes on the inside to the outside, and as well as taking the planes themselves and seeing them in 3D. Like the roof on the left, you're looking at you're looking at a plane that's at an angle, so it's a foreshortened version. And while this looks like a point cloud imagery, this is actually just a very, very simple planes and a mixture of line drawings and rectified photography. And then this all we had had a breakthrough moment with the work we did at Montpelier, James Madison's home here in Virginia. That was a much larger building owned by the DuPonts, and we were charged with asking, do we have enough historical material to faithfully bring it back to the way it was in Madison's time? And it was there was plenty of material, and the whole project is now up and running, is now completed. But there were a couple of things that were also fun sort of discoveries at that time. And one was this notion of having layers of data, so that here as we excavated and did investigations into the building, such as this showing the location on the upper left. On the lower right, you can see how there were a series of rectified images that documented findings as you went through in like layers, which now we call that 4D. Also, with rectified imagery, we could also work on an urban scale. This project was in Vladivostok in Russia, where we were charged with, I think, 75 blocks of historic facades, 5 miles or so of documentation to be captured. We had a week to do it, and so we went through and used photogrammetry to get our precise points, so that things would be rectified to scale. But then we used, instead of doing any drawing, we just used the rectified images to create the streetscapes. And there are lots of errors inside of a rectified image like this when you have a very three-dimensional situation. But it was a great way, really the only way we knew how at the time, to capture all that data and represent it faithfully with such wide, with such a large amount of data. And then just take a break here, because that's sort of all some of the notions that I was working with. But during this time, the software was starting to become automated, where instead of having a user have to enter in data to figure out where cameras were related to each other, that started to become automated. And then once that was automated, the other thing that started to become automated as well was taking the camera work and starting to create point clouds. And for a while, the point clouds in photogrammetry were sort of like what you saw earlier with the difference of 10 years with the laser scan point clouds. They were very sparse, and then they've become richer and richer, so that now we've got really a total convergence where laser scanners and photogrammetry are now making the same thing, which are these point clouds. And you can take that and look at now you can look at that and say, is this a point cloud or is this a photograph? The other thing we can do with that's been really exciting with point cloud imagery is in order to map some curved surfaces, we're able to flatten them out and develop them, and so in a way that's completely gets rid of the notion of dividing buildings into panels and flattening them out. So we're totally in with point clouds now. This is a sculpture, totally non-architectural form, totally organic form that's captured with photographs and can be analyzed a number of different ways. This is a building in Manhattan, which we shot mostly from grade, but a few shots from rooftops that we can create a point cloud and then fly around sort of like a virtual drone, even though there were no drones used to create this imagery. And then lastly, this is a project from last fall that I did, which is at the dome in the state capital of Kentucky. And this is using drone imagery, ground photographs, rooftop photographs, as well as laser scanning, all in one project. So we're all working sort of on the same page at this point, and there's a lot of convergence. Equipment-wise, one of the advantages that I see is the flexibility of getting everything with just a camera. You can put a camera up on a mast. Obviously, cameras are mounted onto drones, so that's a great way to collect data. You can even do work with iPhone photography. And this has been, with COVID, this has been a real bonus for me, because I've been able to collaborate with people all over the country, where I do some training by phone. They send me pictures and I can send back point clouds. The limitations, so we're in opportunities here. So it's functional with low cost equipment. The remote, okay, so I covered that. The one point there, the data coverage, multiple points of view, that's important, because instead of having, one of the big things that we're all struggling against are data shadows. And with photogrammetry, you're not getting scans from a single point of view. You're always getting oftentimes hundreds of points of view with different, each image. And so you can see around things like trees or furniture, different things that would be blocking you. But still, access can be an issue. Having neighboring buildings can make your camera's angles very difficult. So you do have differences with data shadowing, and then lighting is also an issue. When you have a very crowded room, shadows can create all kinds of problems. So that's another issue that sort of says that to do this at a high-end level, there's a lot of skill that's needed. But there are also opportunities at the low end through collaboration. So it's a wide open field, really, and lots going on right now.
Thanks, Peter. So I think, Matt, if you want to go through this pretty briefly, we could just talk a little bit about drones.
Thanks, John. Yeah. So, you know, and I think John mentioned this earlier on too, you know, we couldn't talk about modern documentation without bringing up drones. You know, about modern documentation, because this is something that's been very, very new, you know, recent. But I think I speak for myself and Peter. You know, the technology behind what the drones are actually doing isn't that new, because it's mostly photogrammetry. Now there's scanners on drones. Really, you know, the big thing with drones is the ability to get up and get higher places that you weren't able to previously. You know, that's sort of like the evolution. You know, this is a picture of one of our latest LiDAR drones. But yeah, sorry, yeah, you can go to the next one, John. You know, and really what drones are mostly used for is obviously, you know, taking aerial photos from the air. I don't have any, you know, good photos of a building surface, but they're really good for acquiring data and especially over vegetated, you know, stuff. If you have the LiDAR is really good for that. But it's really it's a lot of the same types of processes that Peter was talking about, where you're taking multiple photos, and stitching them together, which actually kind of leads us to some of the challenges. You know, so one of the biggest challenges, you know, we get a lot of, so we have our own drone fleet, but we get a lot of calls and people saying, hey, you know, can you go fly my site? You know, can I get the photos by the end of the day? There's a lot more to that, you know, if you're really doing for a full, you know, drone data capture project. You know, there's a lot of planning that's involved. There has to be a lot of overlap. So I'm sure Peter can tell you, you know, get into the science behind how much overlap you need from photo to photo in order to make a great photo mosaic. And it's a lot of information. So, you know, it's easy enough for somebody to take a drone and go up and take one photo, but if you want to turn that into a photo surface, that's a lot more involved. The federal restrictions on the drones have loosened a little bit over the years. So when it first came out, you need to have a pilot's license, you need to have airtime. Now there's actually a whole new separate FAA licensing schema and tests that you could take, but you still need to have those, especially if you're flying this as a commercial or as a business. Any commercial use of a drone, you have to be licensed with the FAA. So that's, you know, a lot of people say, oh, I'll just go fly it up. I have one on my own. But if something happens, God forbid anything happens, you know, there's a lot more things, you know, there's a lot more liability involved. And, you know, following on that too, there's also, you know, a lot of owners, you know, we've been working with some energy companies, and a lot more people are clued in now. So now you need to have different types of insurance if you want to fly a drone on their property. So we're seeing a lot of that. So that's some of the challenges with the drones. But, you know, I think I'll turn this back to John. I think we were going to, John was going to close this up and then open up for questions.
Yeah, thanks, Matt. So, you know, we've talked a lot about the technologies today, and obviously, you know, one of the decisions that we have to make on a lot of these projects is, do we use photogrammetry? Do we use laser scanning? Do we use a combination? Before you even make that decision, you're really deciding, well, is this something we can measure by hand or trace from existing drawings if they exist? And so before we close, I wanted to touch a little bit on kind of how that decision-making process works. And based on sort of this experience doing all these diverse projects, how do you make those kind of decisions? And you can see here a couple of the things that I think are really important components of that. The first that I think probably every architecture engineering firm has dealt with is, you know, hey, this stuff's getting less expensive. This equipment is cheaper now. Can I do this in-house? And really that decision comes down to the cost of the equipment, which is certainly getting better, but also the training. You know, you could hand me a laser scanner tomorrow, and there's virtually no chance, even with my experience, that I'm going to get the same quality data that Matt and Sean are going to get from their scan. Or you can give me an iPhone, and what Peter's going to get out of it is going to be a heck of a lot better than what I can, even with the same software. So, you know, it's a matter of, do you do this enough to invest in the training? there's also a component of kind of, I call it focus. You know, we're architects in my case, or engineers. And is our time better spent learning how to do this documentation, which if you learned it 10 years ago, you would be relearning everything pretty much again today? Or is it better to say, I know enough to know what I want and know what I need, and have specialized consultants do that? And obviously that depends on what you need. This is a case where we have an in-house 3D camera that's relatively inexpensive. It's pretty much point and shoot. And it does give you the ability for a remote site, this is actually at the Nashville airport, to be able to see field conditions. You can take measurements of stud wall height back in the office so that you could minimize field time. Something like that makes a lot of sense to have in-house. For us, at least, the capability to have something like detailed laser scanning is really not practical for most of the projects that we're dealing with. Similarly, this is a project where we're doing a window survey at Penn State. We could go and purchase a drone, but we have the ability, in this case, to use Langen as a consultant, provide the drone services to us to do the photography. They know the permitting process. Penn State, the University Park campus, is actually in an airport zone, so there's an additional layer added onto that. And we can focus on what we do, which is the architectural assessment, and have someone who really does this on a day-to-day basis focus on the drone work. The other element, obviously, that's going into the decision is, what are the actual deliverables? So we've talked about how over the past decade or so, photogrammetry and laser scanning have really converged on the idea of this 3D point cloud as the main deliverable that most people are getting when they're using this remote sense of equipment. That obviously was enabled by the software and the capability of computers. That's something that would have crashed a computer 15 years ago, but now has pretty much become the standard deliverable. But we still have to think about things like the coverage and the resolution. So for the example on the left, and we'll see this again later, we didn't need to get much coverage on the lower portion because the focus was really on the column capitals. On a site like the right, you're really looking to try to capture all of the data for this through the laser scan. And you can see here an example of kind of how that might play out, especially on the lower right. That's a comparison of what Peter showed earlier, which is an orthographic representation of a point cloud versus an actual detailed ortho photograph. Important if you're trying to use it to determine masonry staining or stone by stone condition. Probably not as important if you're just using it to create a model of a building. So then you have to think about, okay, am I really picking the right tool? Again, laser scanning, photogrammetry, both of these things are available. And with that convergence of deliverables, a lot really comes down to the recording process itself. What are the constraints on the access and the speed? Peter mentioned the project that we did in Vladivostok. That, particularly at the time, really wouldn't have been feasible to do with laser scanning. We actually had to have the Russian police close down each road for us for about 5 minutes while we did the photography. So it was really important that we be able to literally capture an entire block in probably about 2 to 3 minutes so that we can get out of the way of the angry Russian drivers. Whereas in a case where you have more flexibility in terms of access, you may have a better choice of technology. 4D capture is another component. Is this something that's just going to be captured once, or is it going to be captured multiple times? And that may guide the technology and the deliverable as well. Availability is certainly one. Drones at this point, there are companies that it's essentially a dime a dozen. You can find people who can provide drone flights. When you get into accurate laser scanning for buildings or photogrammetry, there's really constraints on experts who are able to do this kind of work. So at this point, a lot of, especially our most complex projects, our preservation projects, are really converging on what Peter described as that hybrid model, where you can get your consultant team together and you can say, look, here's what we're trying to achieve, and come up really collaborate to come up with some sort of hybrid model that leverages the best of both. You capture the stuff that you have to get from a lift. You can use photogrammetry because it's not as sensitive as having that stable platform. And then some of the terrestrial stuff you can do with laser scan. So how do we actually do that is obviously another story. There's a tendency, obviously, we're all very focused on architecture, focused on design. There can be a tendency to just go to someone like Peter or to Matt and Sean and say, hey, I need a scan, and go to town, give me a price, and you go and do it. We found that it's much more successful if you actually go through a formal process, just like a client would for an architectural project, and develop a real RFP for those services. And obviously there are a few components that are important to define in there if you want to get the best product. The first is the project goals. Just like a design problem, when you're doing a documentation project, you have to know exactly what it is that you want to achieve. In the case of a building where you're trying to obtain information on the exterior envelope, it might not be important to capture the roof. It might not be important to capture certain detailed elements of brick patterning. Whereas if you're doing a project, which you can do with a point cloud, where you're actually trying to determine variations, this was in a floor slab. This was done actually by laser scanning. But if you're trying to determine, okay, where are the high and low points, and you can see the level of accuracy here, if you look at between red and green, just the decimal places, you actually don't need the point cloud necessarily as much as you need kind of this heat map. So that's a very different deliverable than what you'd get if you're trying to do a building. In the case where you're trying to look at detailed masonry conditions and truly map the condition of every stone, this was a project in Philadelphia where we actually wanted to make sure that we were locating the required masonry wall anchors in the mortar joints rather than the stone. And of course, it was a DGS project, so it was going to be public bid, and we had to know the exact number of those anchors, or you were going to get a change order for it. And in this case, we actually needed that orthophotographic representation of this building to make sure that we located on the drawings all of our anchors so they weren't just put through stonework. An example where you're actually using the point cloud to do digital fabrication, that's something that this is an example project, but we're actually looking at that right now, is how can we do a replacement of a terracotta column capital using this point cloud, and actually prior to the bid, provide the contractor with an accurate 3D model of exactly what they want to fabricate so that we can get them to construct it. And that's going to, again, be a very different scanning process than if you're just trying to model a building. Next element is really determining what kind of control points you need. Laser scanning and photogrammetry can be done with or without survey control. There's a level of accuracy that is helped by having that survey control, but also you get the ability to do what Peter was talking about, that 4D documentation at a larger scale. So a lot of our projects, when we do laser scanning, we'll actually go out and we'll set in the real world a monument that represents the 0, point that we're going to use in our Revit model. So whether you go through construction documents, shop drawings, it doesn't matter. That Revit model is actually linked to a real world scenario. You can also use it to combine technologies. So this was a project where we used laser scanning to do the interior, a combination of laser scanning and photogrammetry on the exterior. We did traditional survey control, but then on some of the interior elevations, using the targets that were set by laser scanning, we literally just took photographs, rectified them in Photoshop, and they were close enough. And we were able to reference those in using the targets, and we were able to get enough accuracy without having to use the same technology on the inside. Procedure and access. It's really important in an RFP for documentation to delineate exactly what the constraints are on accessing the site. And this is the example of that Penn State drone survey where we're trying to figure out exactly what it takes and how to get the permissions to fly this unmanned aircraft so we could do our window survey. And that's something that needs to be delineated in an RFP. Equipment. Again, I'm an architect. I don't know the difference between the laser scanner in the middle and the one on the left in terms of output, but it is often helpful to ask in an RFP for a submittal where you say, prior to the beginning of scanning, tell me what equipment you're going to use to scan it. A lot of times that's just informational. We have to trust the experts that they know what to use, but it is nice to be able to identify, okay, this is a scanner I got last time. Why are we using a different one? Is there going to be an issue with compatibility or anything like that? And then finally, it's about the deliverable, right? At the end of the day, what are you asking for your documentation consultant? Or a lot of this applies to doing it in-house. What are you actually asking them to provide? A lot of times we'll have an interim deliverable where there may be those survey control points or a partial point cloud where you can start to see, hey, is this importing into Revit correctly? And then a separate final deliverable. But it's always nice to have those interims so you can sort of check, hey, is everything working? Is the import going correctly? When I start to put this into, whether it's AutoCAD or Revit, am I seeing distortions or differences between what the point cloud says and what the existing drawings say? Similarly, how am I actually aligning this in Revit? Am I asking the consultant to do some of that work for me and lay out exterior building lines in the point cloud, or deliver me a Revit model where the point cloud is already linked in? Or are we doing that on our end and simply having the consultant give us the raw point cloud data, which we'll then use to build the Revit model? So that's sort of, I think that kind of concludes what we wanted to talk about today. So we'll open it up for questions.
Feel free to unmute yourselves or use the chat to ask any questions that you may have.
That was easy.
I guess we have no questions.
All right.
Well, with that, thank you all for joining us today. Thank you for your expertise on this topic. We really appreciate your presentation. And thank you to Tyler with Performance Roofing for sponsoring today's session as well. And with that, I think we'll bring it to a close for today. Thank you, everybody.
Thank you.
Thanks a lot, everyone.
Bye.